Hi, in the previous video we looked at how we can draw a hyperbola if it is in the form y is equal to a over x plus p plus q. In this one we are going to look at how to find the equation of the hyperbola if the graph is already drawn. Let's look at this example. The hyperbola is defined by y is equal to a over x plus p plus q. We have to determine a, p, and q. So we need to find what is the value of a, what's the value of p, and what is the value of q. Recall that the q value is the horizontal asymptote, which means that the q is just minus 3. Also recall, to find the equation of this line, we solved x plus p is equal to q, which means if this is minus 2, then that should have been a plus 2. So we put there a plus 2. And another thing is to recall that in the previous lessons about the parabolas, the a value was the last thing to find, which we are going to do as the last thing to find as well. Now let's do this problem. So we've got to find this, the substitute values. So y is equal to a over the x. Now we said instead of plus p is plus 2. So it's a plus 2. Then instead of plus q is minus 3. It's minus 3. Now we've got these. The last thing to find is a. How do you find a? We'll substitute a point which is on the graph that we haven't used. We can't substitute the one for 2. We can't substitute the one for minus 3. We're not going to use this because we already used them. So we'll use that other point, which is 4 is to minus 1. X is 4. Y is minus 1. So minus 1 is equal to a over x is 4. X is 4. So it's 4 plus 2, then minus 3. If I take minus 3 across, it's minus 1 plus 3 is equal to a over 4 plus 2 is 6. So minus 1 plus 3 is a 2, which means that that is a over 6. So to solve for a, I'll cross multiply. So 6 times 2 gives us a 12. So this gives us an a value. Now we know that a is 12 from this, so we can answer the question. Therefore a is 12. What is p? We said p was a plus 2. And what is q? We say q is equal to minus 3. Let's look at another example. It says the hyperbola is defined by y equals a over x plus p plus q. You've got to find the values of a, p, and q. Remember, a is the last thing to find. We don't know it, but you must find p and q. We know that q is the horizontal asymptote. It will be this line. And this one comes from here. However, here, they just give us coordinates. That's an x value, which means that the number here is 1. That's the y value, which means the number here is 2. Therefore, so now we know what is q, because q comes from the horizontal asymptote. There, so it's 2. So we know that we've got 2 for there, so that's a plus 2. And we said this one here came from solving for x there. So if this is 1, so there we put minus 1. Signs are different. Therefore, now we can try and find the thing. So we substitute. So y is equal to a is the last thing to find. So x, then minus 1, then plus 2. Now to find the value of a, we substitute a point which we haven't used. We are not going to use this point because it gave us this. So we are going to use another point which is on the graph. You've got to choose which one is easier for you. The 2.5 looks difficult, but the coordinates of this point here is x is 2.5 is to 0. But the coordinates here, the x value is 0 and that's the y value. So this point is 0 is to 5. I think this one is easier to use. X is 0, y is 5. Y is 5, I substitute 5 is equals to a, which I don't know. X, we set is 0 minus 1, then plus 2. So 5 is equal to a over 0 minus 1 is minus 1, so plus 2. So I can take it 2 across, so I'll get 5 minus 2 is equals to a over minus 1. 5 minus 2 is a 3, which is equals to a over minus 1 is minus a. To solve for a, take a across, so a is equal to, take 3 across, minus 3. So a is minus 3. So now I know the answers. Therefore, a is minus 3. And P is, we said P was minus 1, and Q is a plus 2. Let's try another one which is similar to what you did last time, but it just extended it a little bit. They say here, you've got to sketch the hyperbola. Sketch the hyperbola y equals 6 over x minus 1, where x is greater than 0, where x is a positive number. Now let's look at this. We know that y is 6 over x minus 1. So because there's a positive 6, it means that the arms should be in there and there. To draw something like that and like that. But now we've got a minus 1. This thing did not shift. It only shifted up, which means that I've got a horizontal asymptote of minus 1. I'll use a pencil so that makes things easier. First, let's say here I've got my horizontal asymptote like this. I'm using pencil. Right, now we know that the graph has shifted down 1 unit. So it means that this is minus 1 here. So the arm is here, so if you shift down, it's going to cut here. So graph will be something like this, and also something like that. It's not going to go sideways. Okay, so but now because the graph cuts there on the x-axis, we've got to find what is the value of x there. But there are things that you need to know. They said they only want the graph where x is greater than 0, meaning that they are looking for the part where the x is bigger than 0. The part where x is bigger than 0 is the part on the right of 0. So they don't need the part which is on the left. That's why I use pencil, so that I can erase the part that they don't need. Otherwise, they may penalize me in the exam because they don't need this part which is less than 0. They only need the part which is on the right. So the only part they need is that one which is dotted like that. Now I can use my red dotted line like this, like that, and therefore I can now draw my graph like nicely. The thicker pen, there we go. So there's my graph, and therefore I only need to find the x-intercept there. How do you find the x-intercept again? So we said that's minus 1 there. Find the x-intercept, you make y 0. Y is 0 there. So if y is 0, so therefore now for 0 is equals to 6 over x minus 1. Solve for x, take minus 1 across. It's positive 1. It's equals to 6 over x. Solve for x, I can cross multiply. X times 1 is x, is equal to 6. So the x-intercept is 6 over there. So that is our x-intercept. Okay, so therefore now you can try and do a few problems of your own from your own textbook, Siavola Maths book, that is in grade 11, chapter 5.3, exercise 5.14, numbers 2, 3, and 4.